Good afternoon and most welcome to Heidegger 1342. And today I will discuss the subject quantum cognition and creativity. The connection between a more creative state of being, a more open one. You could call it the superposition one of understanding, where things are not put into the open, explicitly defined, under the light, as Martin Heidegger would put it, but instead a creative, joyful, curious state, and to be seen in contrast to the present Newtonian stillness, staticness, and determinism. I will read the abstract from Souparno Roy et al.'s paper, and then I will continue to flow over another paper by Selmayr. Creativity, defined as the tendency to generate or recognize new ideas or alternatives, and to make connections between seemingly unrelated phenomena, is too vast a horizon to be summed up in such a simple sentence. The extreme abstractness of creativity makes it harder to quantify in its entirety. Yet a lot of efforts have been made both by psychologists and neurobiologists to identify its signature. A general conformity is expressed in the free association theory. That is, the more freely a person's conceptual nodes are connected, the more divergent thinker, also creative, he or she is. Also, tolerance of ambiguity is found to be related to divergent thinking. In this study, we approach the problem of creativity from a theoretical physics standpoint. theoretically for the initial conceptual state. The next jump to any other node is equally probable. And non-deterministic. Repeated intervention of external stimulus, analogous to a measurement, is responsible for such jumps. And to study such a non-deterministic system with continuous measurements. Quantum theory has been proven the most successful time and again. We suggest that this collection of nodes form a system which is likely to be governed by quantum physics and specify the transformations which could help explain the conceptual jump between states. Our argument from the point of view of physics is that the initial evolution of the creative process is identical, person or field independent. To answer the next obvious question about individual creativity, we hypothesize that the quantum system under continuous measurements in the form of external stimuli evolves with chaotic dynamics, hence separating a painter from a musician. Possible experimental methodology of these effects has also been suggested using ambiguous figures. First, a quote from Pablo Picasso. Others have seen what is and asked why. I have seen what could be and asked why not. From the very dawn of civilization, creativity has been inspiring and reshaping human existence continuously. It was creativity that gave rise to the likes of Picasso, Da Vinci, and Einstein. Who with their endless wonders on and off the paper changed the course of human history. And civilization time and again. We in turn have strived to understand the experiences of them. And have questioned what, if anything, we ourselves have in common with these amazing individuals. Creativity is the development of new ideas and original products in a novel and appropriate way. And theories and ideas about understanding the creative process stem from far back in history, since it is a particularly human characteristic. Though it started as far back as the late 1800s, The systemic search of creativity blossomed in the 20th century, where its roots have been searched in the lights of the plethora of diversified disciplines. Psychoanalytic approach. Freud's discussion of creativity as the sublimation of drives. Winnicott's work on development, which makes creativity central and intrinsic to human nature. Cognitive approach originated from Galton's work on hereditary genius. Also includes Mednick's exploration of the associative process. And Guilford's exploration of divergent production of ideas and products. Behavioristic approach. B.F. Skinner's discussion of effect of chance mutation in behaviors. Neurological, biological approach. Using modern instruments like EEG or functional magnetic resonance imaging, fMRI, to pinpoint the brain areas activated during creativity. The latter half of the 20th century of creativity research is dominated by psychometrics. Psychometric approaches to creativity were begun by psychologist J.P. Guilford. Who developed a tool for measuring the extent of divergent thinking. Which he later developed into the concept of divergent production. Divergent production or thinking, also loosely called lateral thinking. My parenthesis here, a neologism by Edward de Bono, is a method used to generate multiple related ideas for a given topic or a problem. Despite criticism, the idea of divergent thinking has become important in the scientific study of creativity because many widely used tests for creativity are measures of individual differences in divergent thinking ability, like the Torrance tests of creative thinking. Free association theory of creativity. Divergent thinking tasks have been widely used because traditionally creativity has been understood in terms of the accessibility of concepts in our long-term memory systems. Concepts are connected in our brains in semantic networks. Where ideas are connected like a spider's web. And each node is an accessible from a street via other nodes. Psychologists have proposed that individual differences in creativity are due to differences in whether these kinds of associative networks were steep or flat. Those with flat networks have numerous and loose conceptual connections, enabling them to be more creative. Those with steep networks tend to have more logical, linear associations between nodes. In this paper, we investigate this very idea of divergent thinking from a theoretical point of view of physics. More specifically, quantum physics. Why use physics? And why quantum physics? Answer to the first question, why should we not? Brains are nothing more and nothing less than atoms joined together to form molecules. Bounded into specialized cells, that is, neurons. Which can communicate with each other. Like everything else in this world, neurons and brains must obey the laws of physics. As for the second part of the question, at first sight, it may seem bizarre or even ridiculous. To draw a connection between creative process or any such higher brain functions for that matter. Something lying within the realm of day-to-day human behavior. On the one hand, and quantum mechanics. A highly successful theory devised mainly to explain microscopic subatomic phenomena on the other hand. Yet there are good scientific reasons to do so. Quantum theory with astonishing counterintuitive ramifications. It is the best empirically confirmed scientific theory in human history. It is essential to every natural science and its practical applications, such as the laser and the transistor, have paved the way for new groundbreaking ideas. The application of quantum theory to human cognition and also creativity is driven not only by deep resonations between basic notions of quantum theory and psychological conceptions and intuitions, but also by the potential of the theory to provide coherent and mathematically principled explanations for the puzzles and challenges in human cognitive research. A very brief overview of the unusual nature of the theory is presented as a precursor to the idea we want to convey. Review of some prominent quantum phenomena and properties. Discreteness of nature. Quantum physics emphasizes that our world is built on discrete particles that are bound in finite systems of discontinuous energies. Unlike classical physics, where energies have continuous distributions, also in the neurological framework, to describe the dynamics of neuron firings, evidently a discrete and discontinuous process. Quantum theory can be used for more precision instead of existing classical ideas. Wave-particle dual nature. Particles like electron or photon can exhibit both particle and wave characteristics. An event that is entirely non-classical in nature. Proposal of the manifestation of this property in mind-matter relationship is not an alien notion. Quantum tunneling. Quantum wave effects allow tunneling through an energy barrier which would classically be unsurmountable. That is the penetration through a dense wall. It is nothing less than magic, my comment. It is suggested that macroscopic spread of quantum effects in human brain may involve the tunneling effect. quantum superposition. Before a measurement, a particle can be in a state which is a superposition of all the possible energy configurations available for the particle. Dealing with a mental space which consists several possible states, the role of quantum superposition is surely undeniable. Indeterministic nature. Quantum process is indeterministic. That is, the process of measurement introduces indeterminism. Unlike classical counterpart, the actual outcomes of an experiment are not uniquely determined by the theory. Neurological investigation has not been able to determine the exact state of the psychological functions in any sort of experiments. Limitations of the deterministic ideas definitely point towards a quantum intervention. Quantum entanglement. Entanglement is the inseparable quantum correlation of two or more particles or degrees of freedom which determines the states of these two spatially separated systems. Simultaneously, as soon as one of them is acted or measured upon. Entanglement effects in human brain have been a topic of several researches, including memory or cognitive processes. These are some of the unique phenomena that marks the stark differences between quantum theory and classical physics, making the former more suitable to approach the hard problem of explaining the higher brain functions. Including creativity, quantum leap interpretation, let us steer the reader towards the path we hope to take. From the viewpoint of cognitive neurobiology, we now well understand the nature of nerve cell activity, the creation of action potentials, ion exchange, the use of energy, axonal transport, the vesicle cycle, and the production, cycle, and breakdown of neurotransmitters. Yet how these unconscious materials produce the stream of consciousness or perform the individual higher brain functions so smoothly, classical theories are still mum on that. Hence, we take help from the emergent field of quantum neurobiology, that explores these issues with an alternate approach. According to quantum neurobiology, quantum physics is involved in biological processes. And consciousness, memory, and internal experiences. and the process of choice and decision making, which are the products of the warm, wet, noisy brain. Maybe the result of the operations of quantum physics. To make our intention crystal clear, we would like to state that we never claim our interpretation to be the only valid one by which the creative process can be explained. Our argument is that this point of view can help paving the way for a foundation to further understanding this complex brain process. I'll put a little point. Could I borrow a pen? And don't stop. This should be compared to the present paradigm, where evolution, call it progress, is linear. Edward de Bono called this stone logic, where arguments and facts, and why not bits of information, piled up, and in the piling up process a solution or an understanding will slowly emerge from the accumulation of facts or information or objects. That is not the case in quantum mechanics. There is no linearity whatsoever. There is no accumulation of small parts to make up either a solution, the universe, or a human being. Quantum mechanics is taking leaps. Wholenesses spring into becoming from nowhere. All of a sudden, the quantum leap has been made, and this is the act of creativity from nature itself, far from the slow grinding of cause and effect, the linear idea of things pushing to the future. The future in quantum mechanics is here in an instant. Almost in the sense of being uncaused. without an explanation. And this is exactly what creativity is. No invention, no discovery has been made based on previous facts, information, or objects. My favorite example is the one of Ian Fleming, the inventor, or, if you prefer, discoverer of penicillin. And of course, his name is Alexander Fleming. He went from nowhere to have penicillin in an instant. It was caused by something that we would call chance, but has a completely different term in quantum mechanics. It springs from nowhere, or why not everywhere. This is the quantum leap. And since I just decided to make this part of the course, a very short question. Make it short.
Yes, speak of quantum jumps and then the progression of knowledge and understanding, we could compare with James Clear and the 1% rule, and put juxtapose chaos theory that, okay, in chaos theory you have the butterfly, it's so small, the change, so it's of the wing of the butterfly is so tiny, so it's almost no, there's really no change in nature when the butterfly moves its wings, and we can compare it to James Wing's 1% rule. The changes, the improvements are so small that there are really no changes at all, but suddenly you have the result, the jump, the quantum jump, or a storm caused by a butterfly. That was a comment.
Yes, thank you very much, Kalle, and I terminate the lecture here, and have a very pleasant afternoon.
Thank
Bye
you.
bye.